Hello guys, I hope you are doing well. Happy New Year and welcome back to this amazing YouTube channel. My name is Lorna and I'm a planning and evolution engineer. As a planning and evolution engineer, I definitely touch on various aspects of IT because planning cuts across so many areas. So if you're new to this YouTube channel, karibu sana. This is a YouTube channel where we share various IT information which we feel like is useful for us to grow our career. So remember to check on my previous videos. Remember to kindly watch the videos if you haven't already. Leave a like on each and every video. Also leave a comment. Let me know what you think about the videos, and most importantly, if you feel like there's something you want me to talk about, also let me know in the comment section. And kindly subscribe to this YouTube channel. If you're watching right now and you haven't subscribed, kindly subscribe as you continue to watch. And also remember to kindly share the videos as widely as you can. So in this video today, I hope you can see that I'm sharing my screen with some configuration files, YAML files, and I want us to talk about some of the things that you really need to understand when you're running your applications in Kubernetes. So in my previous video, I talked about how to learn Kubernetes for the first time, some of the things that you really need to know before learning Kubernetes, and how to install Kubernetes. I also provided a link to help you install a Kubernetes cluster. So I hope you went through that video. If you haven't, or if you didn't, kindly watch that video if you don't know how to install Kubernetes cluster yet, so that when you come to this video, you'll be able to run some of the applications using Kubernetes. Because what I'm going to talk about is the different ways of deploying applications in Kubernetes, which I promised in my previous video. I talked about a pod, I talked about a deployment, a stateful set, a DaemonSet, and a service. So this is what I'm going to talk about today, because you really need to understand what these things are before you start deploying applications in Kubernetes, because you need to know how to deploy these things and what are necessary for deploying, and how. Remember, when you are deploying things, applications in Kubernetes, you really need to understand how to deploy different applications. So if it's like a web application, if it's a database, you need to know the different configuration files to use to deploy those applications. Also, if it's persistent, if you want the data for that particular container to persist or not, those are some of the things you really have to understand first before going ahead to deploy the different applications in Kubernetes. So I'm going to start with a pod. As you can see here, I have these different YAML files, and they have a pod over here, pod.yaml. So when you talk about pod, it's actually the smallest, like the most basic deployable object in Kubernetes. So it's mostly treated it's mostly like a single container. It represents a single instance of an application or of a running process in a Kubernetes cluster, and it's mostly one container. But in some cases, you might find that a pod actually has more than one container. So depending on, maybe you want to have a smaller container that collects maybe logs from your main container, then you can have the two in a single pod. So when you have them like that, they are usually treated as one entity. They're not treated separately, because they share IP address, they share the networking, they share the storage, they share everything that the main pod was using. So they are usually also treated as one entity. So it's, as I said, it's the smallest, the most basic deployable object in Kubernetes. So I want to show you how to write a simple configuration for a pod that you can use to create a single container in Kubernetes. So this is how this file looks like. It's a simple one. There's so many things that you can add and aspects as you go ahead to learn so many things. For example, something like volumes. You can actually add a specific path if you want to use a specific path instead of the usual default volume that containers create. You can also use things like maybe resources. Maybe you want to limit resources for maybe RAM or CPU. You can use something called resources and limits and requests. So there's so many things that you can add and aspects, but I just wanted to show like the most basic things that can actually run a simple pod. So here I just provided like the image and the pod which that container is going to run, and so it's as basic as it is. Yeah, so the major things that you need to consider is the kind here. So the kind is a pod, and then under metadata, you just give it a name. You can also give it like a namespace if you want it to be created in a specific namespace. And then under specs, as I said, there's so many things that you can give here, but the most basic thing that you can always give is a container. I mean an image, because definitely you're running a container, and containers run using images, so you must provide an image. So it is as simple as this, and you can also provide a specific port that you want that container to run under. Yeah. Then another thing that I want to talk about is a deployment. So when you run a port like this, it's this simple, but using a deployment is actually the most recommended way of creating, or rather deploying ports, because a deployment gives like a desired state of how you want your port to be. For example, how many replicas you want. If you want to increase or decrease the number of ports, you can actually do that in a deployment. So let me show you how a deployment manifest looks like. Yeah, it's here. So the kind, this is where you really need to begin. You need to provide the kind as a deployment, and then of course the metadata, you have a name, and then you give a label, because this label is really important when you're creating these replicas, because it has to know that all those replicas will be labeled like this, so that when you're running, when you're doing when you're exposing it using a service, then you'll use this label to show that you want to expose these 3 replicas using that specific service. So labeling is really, really important. And then of course, under specs, you give the number of replicas that you want. You want how many containers to be created, or how many ports to be created for that particular image that you are deploying. And then, you know, down here you get some of the specifications, and definitely you must provide the image and the port that it will be running on. There's also so many things that you can add under spec, which you can also learn as you go ahead, but this is the most basic configuration for a deployment. It's the most basic configuration for a deployment. So the thing that you really need to keep an eye on is to provide the kind over here. Also, this is the API version, apps /version 1, and then of course a name, the label, the replicas, how many replicas you want, and of course these the container image. And then once you have this up, I didn't show you how to now run, or rather how to create these deployments or even the pod before. So let me do like an edit so that I can write something. So once you have this, you've created this file, and you already have your Kubernetes running. You can actually it's not part of this, so don't count it as part of the deployment. I'm just showing you how to create the pod or a deployment once you have this manifest file. So you can say kubectl create -f, because you want to specify the name of the file, pod .yaml for the case of the pod that you saw before. And then for this deployment, you can also say kubectl create -f deployment. It depends on the name that you gave. You don't have to call it deployment. You can give it any name. So deployment.yaml. Yeah. So this is how you create your pods or your deployments once you have the configuration files. And then for a deployment, remember I said it gives like the desired state of how you want your cluster to be. In this case, it will be creating 3 replicas. So if you want to change anything, maybe you want to reduce the number of replicas, here you can actually come and say you want 2, or maybe you want to increase to 6, or even maybe you want to change the image to maybe to next latest, or whichever image that you want to use. What you need to do once you make these changes, if you had already created your deployment before, you need to use apply, not create anymore, because it will, if you use create again, it will actually throw an error. So you need to use apply. So you say kubectl apply -f your deployment.yaml. Yeah, like that. So it will actually pick the changes that you've done in your YAML file. So that's it for a pod and a deployment. And as I said, a deployment is actually the most recommended way to deploy your pods. You don't really, it's not really recommended to use a pod as it is, but there are situations that you have to use a pod. But if you don't have to use a pod, deployment is the best way, because still you can actually give different desired configurations that you want your cluster to be like. Number 3, let's talk about a stateful set. So a stateful set, also before I go to a stateful set, one thing I have to mention about a deployment is that it's mostly used to run stateless applications. So when you talk about stateful and stateless applications, stateful applications, we know that they remember the previous state, but stateless don't remember like the previous state. And as you can see, I didn't provide any volume to keep the data, to keep storing the data from this container. So this means that this one will use the default path that containers use. And once you delete this deployment, you will actually delete that particular information for these containers, for these pods that you create here. So this is why it's called stateless, because you delete it, it goes with the information that was that has already been stored when you are running these pods. But when you talk about stateful application, those are the applications that remember the previous state, and mostly they're used for deploying things like maybe databases. For example, if you want to deploy like a MySQL, you want to deploy MySQL database in Kubernetes, you actually have to use a stateful set, because remember, stateful sets, you must provide persistent volumes that they'll store their information in, and then you use what we call persistent volume claims, so that that stateful application is going to use, so that it uses the persistent volume that you provided. So a stateful set, as I said, it's basically used for managing stateful applications. So let me show you how the file looks like. So before I go to the service over here, let's just have a look at how the configuration of a stateful set looks like. So as you can see down here, there's a volume claim. So you first create a volume, a persistent volume, and then you enable it to claim that volume so that it can store all its information over there. So once you delete this pod or this kind of application, you can actually still retain the information that was stored in these persistent volumes. So so it's basically more like a deployment, except that it has this volume, persistent volumes, and then you definitely have to provide the kind as a stateful set, otherwise it has the same configurations here as a deployment, except, as I said, these are persistent volume claim that you provide over there. Another thing that you really need to know about a stateful set is that, unlike deployment, it gives like a guarantee of ordering your pods. Yeah, so if you provide, like, you need 3 replicas, the first, it will actually create these 3 replicas, and the first one will be given like a name of something -0. The second one will be like, if you name them maybe, let me see, a name, name. Okay, you give it any specific name. For example, you call it like Nginx, for example, or MySQL, for example. In this case, let's say you're deploying MySQL database in Kubernetes and you're using a stateful set. So the first one will be MySQL-0. So that will be like the first pod. The next one will be MySQL-1. That will be the next one. And the third one will be MySQL-3, depending on how many replicas that you're actually creating with a stateful set. So the important thing about that, especially if you're running a database, is that if you have MySQL-0 as the first pod created, it will actually treat it as the primary database. So the rest will be like the standby databases. So this primary database definitely will be receiving writes and mostly writes, and then the rest will be receiving reads. So maybe you want to use the rest of the ports for reads, and then you want to use the primary one for writes, definitely, and then it will be replicating to the others. So it will by default treat the first one, the MySQL-0, as the primary database. So that's really, really key when it comes to stateful sets, because remember, especially when you're running databases, you will definitely need to have like a primary database, and the rest are secondary, or the ones that will be serving reads. So so that's it. So it provides that guarantee of ordering your pods. And another also important thing to note about stateful sets is that it uses a certain service called headless service, especially for the first pod. In this case, let's say MySQL-0. So a headless service is actually a service that you give cluster IP as none. Remember, you don't want to have, usually when you create a service, which I'm going to talk about also, is that when you create a service exposes your deployments or your pods to either within the cluster or outside the cluster. So within the cluster, a service that exposes your applications within the cluster is called a cluster IP. So cluster IP is able to tell the rest of the applications that this is how to reach this particular application or this particular pod. So when you say cluster IP is none, it means there is no cluster IP for that particular service. So that means there is no load balancing of the traffic to all the pods running in the background. So that means that each of those pods will be accessed by itself. It's really useful when it comes to databases also, because with the databases, you don't want to load balance, especially if you have your first database as primary and you want to send writes to that particular database. You don't load balance writes to the rest of the databases. So you just want to have this first one sending traffic for writes, and then you want the rest to be reading. So for reading, you definitely have to load balance because you want to read from the many databases, so you also load balance that traffic. But for writing, you just want to take traffic to one pod, and this is where you use a cluster IP of none as a service for that particular pod that you don't want to do any load balancing of the traffic. I hope that is clear. So another important thing to note about StatefulSets is when it comes to storage and volumes. So when you talk about deployment and when you create a persistent volume for deployment, they'll all use the same persistent volume claim, and they'll all access the same persistent volume. But when it comes to StatefulSets, each of the replicas will have their own persistent volume claim, and they'll have their own persistent volume. So that's really, really key to note. And also remember, they're uniquely identified, so the pods are never interchangeable. But the only thing that have to be ensured is that there has to be replication across the pods so that they are all having the same information. Another thing that I also want to talk about is a DaemonSet. So when you talk about DaemonSet, let me show you. So a DaemonSet is another way of deploying pods, but this one makes sure that you just have one replica of that pod running on each and every node. So this is basically used for pods that you want, or applications that you want to make sure that is running on each and every of the nodes. Yeah, for example, if you want to do something like monitoring, you want to deploy a monitoring service on each and every node, right? So if you want to deploy a monitoring service on each and every, you want to make sure that at least that particular monitoring service is running on each and every node. Then you use what you call a DaemonSet. So it will make sure that you create it like this, and then it will make sure that it deploys this pod on each and every node existing in the cluster. Yeah, so that's when a DaemonSet comes in. Another example is maybe like another example, a very good example actually is the Kubernetes proxy service. So that one has to run on each and every node in the cluster. So if it has to run in each and every node in the cluster, it actually runs using a DaemonSet. And any other thing that you want to deploy and you want to make sure that it's running on each and every node in the cluster, you use a DaemonSet. Remember, when you use a deployment, usually what happens is that the scheduler checks which node can actually run this pod, sometimes depending on the resources that a node has. So it will schedule the pod depending on how the node is. But when you want to make sure that at least this particular pod is running on each and every node, you make sure that you use a DaemonSet for that matter. Except the scenarios when you have, maybe you want to taint a node, for example. I think these are some of the things that you learn going forward. You have what you call taintings and tolerations. When you taint a node, it means that you don't want that node to run any pod. So that's what you call tainting. But when you use toleration, it can actually tolerate it and it can still run that pod. So I think you can look at that going forward. But when you don't have all those tainting and toleration and things like that, you're just running the pods and nodes normally. Kubernetes by itself using the scheduler, just schedule pods to the nodes depending on how the nodes are. But when you use a DaemonSet, it will make sure that at least that particular pod is running on each and every node in the cluster. So now talking about the services in Kubernetes. So as I've already mentioned, a service is used to expose the applications or deployments running in a Kubernetes cluster. And I've already talked about a cluster IP. It's one of the services used in Kubernetes. And it's actually used to expose application within the cluster. But there are other service types like node port and load balancer. Maybe you can check on them in the meantime, because I think it's a whole topic on its own and I'm not going to continue talking about them in this video. I think I'll make a video on its own the way we talk about Kubernetes services. So in the meantime, just to check more of cluster IP, check about node port and also load balancer. There are others like ingress, which I think we will actually have that on particular video to talk about. Thank you so much for listening up to this point. I hope the video has been informative. I know I may not have been exhaustive, which is okay. I feel like my videos are mostly to give you like a base of where you can actually build from, and skill yourself until you become an expert. So thank you so much for watching up to this point. Remember to kindly share the video as much as possible, like the video, and please subscribe. So let's meet in the next one. Bye bye.